In inductor, the voltage leads the current by 90 degree. Okay, just wait a minute. In inductor, uh, voltage leads the current 90 degree. In capacitor, voltage lags the current by 90 degree, or current leads the voltage in capacitive circuit by 90 degree. So today we will discuss basically the power in AC circuit. Power in AC circuit we will discuss. So uh, power in AC circuit we will discuss. So basically, what is power? Power is voltage into current. Voltage into current, and in an AC circuit, what happens? Voltage also changes. Voltage changes with time, and current also changes with time. So both are variable with respect to time. So voltage, suppose at any time in the circuit is Vt is equal to V naught sine omega t, and current in the circuit at any time is I is equal to I naught sine omega t plus phi. So what is phi? Phi is basically the phase difference between the voltage and the current. I am taking phi any random phase difference. Okay, phi is the phase difference here. Okay, so in the AC circuit, uh, hello Fawaz,
Yes, sir.
how are you?
Sir, I am fine.
Okay. So I am discussing power in AC circuit. Okay,
Okay.
so basically power is a product of voltage in the circuit and the current. So uh, in DC circuit we have seen power is equal to voltage into current. Uh, in AC circuit, what happens? Voltage changes with time. I have told you, voltage changes with time. So equation of the voltage is V is equal to V naught sine omega t. Equation of the current, I is equal to I naught sine omega t plus phi. Phi is the phase difference. Omega is the angular frequency. Okay, V naught is the maximum value of the voltage. I naught is the maximum value of the current. Okay, so in the AC circuit, power at any time t is equal to voltage any time t multiplied by current at any time t. So power is equal to voltage into current. So put the value of voltage and current in this here. This is V naught and sine omega t. Okay, and this is I naught sine omega t plus phi. Okay. So this is power at any time t. So I can write this equation like this. I can write this as V naught into I naught, V naught into I naught sine omega t into sine of omega t plus phi. I can write this. Okay, now what I want to do, basically in AC circuit, we have calculated the average value of the current. Why we calculate average value of the current? Because current is changing with time. because the current is changing with time. That is why we are calculating the RMS value. That is why we are calculating the root mean square value. Okay. So this is basically your average power. This is basically your average power for full cycle. For full cycle. There is one more point that I want to write. Uh, in AC, both voltage and current varies with time. So you can see from this equation, voltage is also changing with time, current is also changing. So basically we are doing this. Okay. So now, mm, we want to find now the average power. So we have the function of power in terms of time. This power is given like this. Okay. So we want the average power. So if you want the average of something like y is equal to fx is any function, y is equal to fx is any function. I have told you this already. If you want to calculate y of average, then what you will do, you will integrate this from 0 to t fx into dx and 0 to t uh, dx. If you want the average of this function from 0 to t, this limit can change accordingly what type of average you want. So I want the average power. I want the average power. So average power, to write the average power, we can write the average power like this. We can, this is also known as the average power, or we can write the average power like this, var on this. Okay. So in NCERT, the average power is written like this. Basically, this is the power function, and this sign is representing the average. The sign is representing the average. So this is your power at any time t. So we will calculate the average. Okay, now average power. Write the value of pt. What is pt? V naught into I naught sine omega t and sine of omega t plus phi. And I am just writing this as bar. Bar means the average of whole value. Bar means the average of whole value. Okay. So we can write one formula. Uh, there is one formula of sine of a plus b. So this is sine a cos b plus cos a sine b. So what I will do, this is v naught I naught. This is sine omega t. This is sine omega t plus phi. So we will open this. We will open this. So you can consider this as a and this as b. Okay. So this will become v naught I naught, and this is sine of omega t, and this is, here you will write sine a means sine omega t cos phi plus cos omega t write this bar because you want the average. Okay, this v naught and I naught are the hello, is my voice okay, Fawaz?
Yes, sir. Yes, yes.
Fine. So we can now take this bar like this, average of v naught and I naught, and we can write this sine omega t. Okay, so we will do this thing in last. So this is v naught and I naught. Okay, now I will multiply this. This is sine omega t, this is sine omega t. This is sine omega t, this is sine omega t. This will become sine square omega t and cos phi plus this is sin omega t, this is cos omega t, this is sin phi. So this will become sin omega t, cos omega t, and sin phi. There is one bar on whole of this. Okay. Now we can write this like this: P naught, I naught bar, and bar on this sin square omega t cos phi, bar on this plus sin omega t cos omega t sin phi, bar on this. Okay. So remember, for full cycle, the average value of sin omega t, the average value of sin omega t is equal to 0. The average value of cos omega t for full cycle is equal to 0, and the average value of sin square omega t for full cycle is equal to half. Okay, the average value of cos square omega t for full cycle is equal to half. Okay, so we will use this here. So this V naught and I naught are the constant. V naught and I naught both are constant. So we can write V naught and I naught. So average of V naught and I naught will be V naught and I naught, because these terms are constant. So now this bracket, this can be written like this: sin square omega t var and cos phi var, like this. This becomes sin omega t cos omega t and sin phi. Okay, so from here you can write this is V naught, this is I naught, and the is the average of sin square omega t, half, and uh, cos phi, phi cos phi is constant. Phi is the phase difference, so phase will be the constant here, na? Phase is constant, so means your cos phi will be constant. So you can write cos phi like this: bar of the cos phi will be cos phi, because cos phi is a constant quantity. Now average value of sin omega t is 0, cos omega t is 0, so means this term will become 0, this whole term will become 0. So what we will get, V naught I naught cos phi divided by 2. If you remember that, I have told you root mean square value of the current is given by
Sir,
I naught. Yeah.
sir, cos phase only.
Hmm?
Cos phase only, or
cos
for
cos phi
yeah,
is
yeah, yeah, sir, yes.
hmm?
Yes, it will come same as that only.
Yeah, why cos phi is same, na? Here this you are saying this, na? Why this bar
Yeah,
given
yes, yes,
like,
sir.
yeah, why this? Because na, this cos phi, what is the meaning of this? Meaning of this bar is the average of cos phi for full cycle, the average of cos phi for full cycle. But this cos phi is constant, this cos phi is constant. For example, if you are if you have a 2 2 2 2 and 2, and if you want to find the average of this 2 2 2 2 2, so again you will get 2. So how you will find the average? Sum of 2, 1 2 2 2 3 2 4 2 5 2 divided by 5. So this is 2, this is 10 by 5. So again you will get 2, na? So means the average of the constant quantity is same. Okay, that is why I have written this cos phi as cos phi. Got it?
Okay. Yes, sir.
Hmm. Okay, so IRMS, I have told you IRMS means root mean square value of the current is written. IRMS is equal to I naught by root 2. Okay, and VRMS can be written as V naught by root 2. Acha, what is I naught and V naught? Avaz, what is I naught and V naught?
Sir, maximum current and
Hmm.
maximum
Hmm. Voltages.
voltage.
So I can write this 2 can be written as na like root 2 into root 2. So this can be written as V naught by root 2 multiplied by I naught by root 2 and multiplied by cos phi. Multiplied by cos phi. What is V naught by root 2? VRMS. What is I naught by root 2? IRMS. What is cos phi? Cos phi is cos phi. So this is your average power. This will be your average power. VRMS, IRMS, cos phi. And this cos phi is known as the power factor. Is known as the power factor. So if you want to calculate this power factor, na, so what you will do, you will draw the phasor diagram for series LCR circuit. So for the series LCR circuit, if you will draw the diagram for the resistance is like this. This is the resistance, and here is the inductance L, and here is the not the inductance. This is XL, inductive reactance, and here is XC. I have told you na this thing in the last class. See, this is the diagram R, XL, and XC. Okay, this will be the diagram if XC will be greater than XL. That is why I have told you in the last class. Revise your notes. So we can take any one of the XL should be greater than XC or XC should be. I am taking XL greater than XC. So this diagram will be reduced to like this. This is R. Here will be XL minus XC. And here resultant of this will be the Z. What is Z? Z is the impedance. I have told you na, Z is the impedance. And what is phi? This is phi. This is the diagram of the this is the resistance, and this is the inductive reactance. This is capacitive reactance. If XL is greater than XC, so this will be the diagram. This will be the phasor diagram, and from this phasor diagram, uh, you can find the value of cos phi. You can find the value of cos phi. Basically, I want to find the cos phi. Okay, so cos phi. What is this distance? I have told you length of the arrow is representing the maximum value R, maximum value of quantity. Okay, so now you can complete this triangle, and you can this is a right angle triangle, so this is the right angle. So if you want to find the cos phi na, so cos phi is given by base y hypotenuse. So base in this triangle is this R, and hypotenuse in this triangle is this Z. Length of this arrow is Z, so R by Z you will get. So basically your cos phi is R divided by Z. Cos phi is R divided by Z. Cos phi is R divided by Z. So these two formulas you should know. Okay, these two formulas: average power and this is power factor. Power factor. There is one another way to calculate the power. Uh, by the integration method, I have told you. If here I think I have told you, if you have a power this na, this power you have power at any time t, If you want to find the average of this for full cycle, then you can write this Pt dt 0 to t divided by dt 0 to t. So you can use this method also for calculating the average power. Okay. Okay, Fawaz and Nida and Hamza, all of you, if you have any doubt, then you can ask me right now. Otherwise, you should note this. Nida, you were absent in the last class, so uh, if you are not getting this properly, so you can check out the previous lecture. Okay, then you will get it properly. Otherwise, there will be problem because uh, hmm, because these things, na, these things, this how to write this equation and how to write this, all these things, how to write this and this diagram and this thing I have told you in the last one. So maybe there may be a problem for you to in understanding. So you can check out that. Minda, your writing is very fast. Oh, Fawaz has completed. I think he has completed. Okay, Hamza, taken the screenshot.
Yes, sir.
Okay, so got it now. This thing I have told you. This is not the DC circuit. This is the AC circuit. So in AC circuit, what happens now? Voltage changes with time. Voltage changes with time. Current also changes with time. And when I have told you the AC generator, here I have told you the equation of voltage or EMF is given by V is equal to V naught sine omega t. So here the voltage is in terms of the sine function. So this thing you should remember. Okay, so write down this. Write down properly. Okay. Otherwise, you will not get what I have done here. This bar means average value. Okay, bar means the average value. There are different way to write the average values. So this formula I have used this formula. Okay, okay, Nida, fine. आप लोगों को ये समझ में नहीं आएगा जब तक आपको बेसिक्स इसके पता नहीं होंगे, ठीक है, जो मैं प्रीवियस लेक्चर में बता चुका हूँ. स्क्रॉल अप और डाउन, स्क्रॉल डाउन और अप.
Down, down.
डाउन डाउन. ओके. हमजा, हैव यू टेकन द स्क्रीनशॉट ऑफ दिस? बेटा रेगुलरली टेक द स्क्रीनशॉट्स if I am scrolling down. I think he has taken. Hamza, take the screenshot. Okay, very good. Fawaz, completed? Scroll down.
Yes, sir.
So now it's okay. So, so what is the formula of average power? Average power is this. Uh, Average power. P average is given by V RMS into I RMS. What is the meaning of RMS? Root mean square into cos phi. And what is cos phi? R by Z. So you can write this formula in this term also. P average is equal to V RMS I RMS and cos phi is equal to R by Z. So in this form also you can write this formula. Okay, so now we will discuss the power factor. We will discuss the power factor for different circuits. For different circuits, we will discuss the power factor. So one by one, we will discuss power factor. Power factor is basically cos phi. And what is phi? Phase difference between the voltage and current. What is phi? Phi is phase difference between voltage and current. Voltage and current. Okay, power factor. Okay, so if I am taking a circuit, suppose first I am taking pure resistive circuit, pure resistive, pure resistive circuit I am taking. So pure resistive circuit means there is only one resistance connected with an AC source. This is the resistance. So in this case, both the voltage in the circuit and the current in the circuit are in same phase. So are in same phase. Same phase means phi is equal to 0. Phi is equal to 0. So what will be the power factor? What will be the power factor? Power factor is given by cos phi na. So you can write power factor in short, PF, power factor. So power factor will be cos phi. Cos phi. What is phi? Phi is 0. So this is cos 0. Cos 0 is equal to 1. Cos 0 is equal to 1. So basically power factor for pure resistive circuit. For pure resistive circuit, the power factor is equal to 1. Now second example, if we have a pure inductive circuit, we have a pure inductive circuit. This is an inductor, have the self inductance L, and this is a AC source is connected with an inductor. So in inductor, what happens? In inductor, what happens? The voltage leads the current by pi by 2. Voltage leads the current by pi by 2, by 90 degree, pi by 2 or 90 degree. So what is the phase difference here? Phase difference between the voltage and the current, you will get 90 degree. And if you will calculate the power factor, that is cos phi, cos phi. So you will get cos 90, and cos 90 is equal to 0. So power factor of pure inductive circuit. What is this circuit? Pure inductive. Pure inductive circuit. Number third, pure capacitive circuit. Pure capacitive circuit. This is a capacitor connected with an AC source. This is the only capacitor connected here. So in the case of the capacitor, the current leads the voltage. Current leads the voltage by pi by 2. Current leads the voltage by pi by 2. So what is the phase difference between the current and the voltage? Again 90 degree. So what will be cos phi? It is cos of 90 degree again is equal to 0. So power factor in case of pure resistive circuit is equal to 0. Okay, so if we have, this is fourth na, if we have a series LCR circuit, series LCR circuit means resistance is connected in series with capacitor, and this capacitor is connected with an inductor. Capacitor is connected with an inductor, and all of the three are connected in series with an AC source. So this has the resistance R, capacitance C, inductance L. So we know how to draw the phasor diagram. How to draw the phasor diagram? Phasor diagram is very, very important. How to draw the phasor diagram? So resistance will be like this. XL will be like this. XC will be like this. Okay, so if your XL is greater than XC, so you can say that this diagram will be like this. Just I have told you XL minus XC in this direction are resultant, you will get Z and this will be phi. So when you will calculate the power factor, that is equal to cos phi, then you will get R by Z. So power factor of series LCR circuit is R by Z. R is the resistance, Z is the impedance. Series LCR circuit. And what is the formula for calculating Z? Z is given by under root of R square plus XL minus XC square. XL minus XC square, or you can write XC minus XL square also, because this is the whole square. If you would write XL minus XC square, or you would write XC minus XL square, the result will be same. Okay, the result will be same. Okay, so write down power factor. Scroll down. Okay. Nida completed. Hamza, take the screenshot. Okay. Beta written
Yes.
Fawaz, Nida,
Yes.
and Hamza. Okay. I am saying again and again, phasor diagram, revise the phasor diagram, how to draw the phasor diagram for different circuits. Otherwise, there will be problem, and you will say that uh, you are not getting. Things are going out of your head. The reason is that if you do not know the basic concepts that I have already told you, then but I'm trying that each and everything should be clear to all of you.
Sir, can you scroll?
Hmm. This is like I have drawn this diagram now. So if you do not know about the phasors, then you will not understand this properly. Why I have written this Z, why I have written this R in this direction, why V XL minus XC is there. I have already told this diagram, this graph, this phasor diagram in the last class, and this also I have uh, told you in the last class. I have just supposed here XL is greater than XC. You can suppose XC greater than XL. Then also you will get R by Z. Then also you will get R by Z. Hamza, take the screenshot.
Done, sir.
Okay, so if you suppose if you are taking XL, what is XL? What is XL and XC? Can anyone tell me? Nida, do you know what is XL and XC? You can say simply yes or no. What? So okay, yes. Means what is XL and what is XC? So XL is inductive reactance. XL is inductive reactance. Hamza, do you know what is XC?
No, sir.
Hamza, okay. So Xc is known as the capacitive reactance. Capacitive reactance. And Z is known as the impedance. Okay, impedance. That is known as the impedance. So Nida, write down this, and this also. And Hamza, take the screenshot. Hamza, do not take the screenshot because in the last class you were present, so I have already written.
Yes, sir.
Uh, okay, good. Okay, so after this, we know that the average power is given by Vrms into IRMS into cos phi. And what is cos phi? This is Vrms and IRMS, and cos phi is equal to RYZ Vrms. Okay, so we know that in a circuit, the peak current is equal to the peak voltage divided by the resistance. Peak current is equal to the peak voltage divided by the resistance. Not the resistance, impedance. Impedance. I am talking about a circuit containing the inductor, capacitor, and the resistance in series. This type of circuit. This is the inductor, this is capacitor, this is the resistor. So in case of this uh, circuit, the current will be maximum current in the circuit equal to the maximum voltage or potential difference divided by the impedance. That is the impedance. Okay, very good. Now you can just divide it by under root 2. You can write this current like this, and V naught by root 2. Okay, and you can write this. We can write na root 2 here and root 2 here. Root 2 and root 2 will be cancelled out, so there will be no effect on this equation. So what is I naught by root 2? Who will tell Fawaz what is I naught by root 2? I naught is the peak current divided by root 2. Hmm?
IRMS.
IRMS. Very good, Fawaz. IRMS. And V naught by root 2 is VRMS. VRMS divided by root 2. Now, if I want to write the power in terms of the voltage only, in terms of the voltage only, then this is the average power. This is the formula of the average power. Suppose I am supposing this is equation number 1. So what I will do, I will put this value from equation 1. So we can put this value of IRMS. So average power will be IRMS is VRMS divided by root 2. Okay, divide by root 2. Just a minute. What I have written? Actually, this will be Z na, because this V naught by root 2 will be VRMS, okay, and divided by Z, okay. So average power will be current instead of current. This is the formula of the power VRMS, IRMS, and into R by Z. So instead of the IRMS, you can write VRMS by Z, and here is VRMS and into R by Z. So average power you will get the VRMS square, Z into Z. This is Z into Z, Z square into R. Okay, Z into Z into Z square into R. So this can be another formula. And one more formula you will get for the average power, that is IRMS square into R into Z. Not just a minute. This will be R. Okay, this will be R. So this will be another formula. And if someone is saying what is apparent power, I'm just writing the formula only. Apparent power is given by VRMS into IRMS into IRMS. VRMS into IRMS. Okay, note down. Then we will discuss the another topic. Okay. Okay. Completed. Okay, so 2 points more I will write in the form of note. Number one, if not mentioned, then assume average power. What is the meaning of this? Means if in a question uh, they are asking calculate the power, so means there you will calculate the average power. Or if some power is given in the question, if nothing is given, no information is given regarding that power, then you will consider that power as average power. Okay. So now, point number second, if not mentioned, then assume RMS voltage or current or RMS current. So if any question, if any where if uh, this is given in AC circuit, the voltage is 5. Okay, that 5 will be the RMS voltage. If in an AC circuit the current is 3, so that 3 ampere will be root mean square current, not average current. That will be root mean square, not instantaneous. So you can note down these 2 points also. Then we will start So now we will discuss the completed. Fawaz?
Yes, sir.
Okay. So now we will discuss very important topic of today. Resonance in LCR circuit. Resonance. LCR circuit. Resonance in LCR circuit. Okay, so LCR circuit is this. This is inductor, and this is inductor. This is capacitor, and this is resistor connected in series with some AC source. This is your inductor, this is your capacitor, this is your resistor. And suppose at any time t in this circuit, the current is I is equal to I naught sine omega t. Because here you have connected the alternating current source, so current will be alternating because current will be changing. That is why the equation of the current is written as I is equal to I naught sine omega t. And here the voltage is V is equal to V naught sine omega t. Okay. So voltage equation I am not writing. Okay, so here this is a series LCR circuit, na? Series LCR circuit. What happens here, na? In the resonance, at resonance, what happens? First, we will draw the phasor diagram. If we will draw the phasor diagram, then voltage across the resistance, here voltage across the inductor, here voltage across the capacitor. Okay, and if I want to draw the impedance phasor diagram, then this will be resistance, this will be XL, this will be XC, and this will be XL, this will be XC. So what happens in resonance? In resonance, what happens? In resonance condition, resonance conditions, what happens? Your XL is equal to XC. Your XL becomes equal to XC. If XL becomes equal to XC, this is XL, this is XC, both will be cancel out. So there will be only resistance in the circuit. There will be only resistance in the circuit. So impedance of the circuit will become R. Impedance of the circuit will become R. Why? From the formula you can see, formula of the impedance is R square plus XL minus XC square, and XL and XC are equal. So XL and XC are equal, so this term becomes 0. So Z become R square, and root of R square is R again. So this circuit becomes purely resistive. Circuit becomes purely resistive. I don't know whether you are understanding or not. So basically, resonance condition is this. Okay, resonance condition is this, and this Z equal to R. This Z equal to R. You can see the impedance of this circuit, the impedance of this circuit, the impedance of this circuit is R square plus XL minus XC square. So this value becomes 0 now. So means here is only R, here is only R. So this value will be the minimum value of the impedance, minimum value. So what happens in the resonance in LCR series circuit? XL is equal to XC. Due to that, the impedance of the circuit becomes minimum. Okay, impedance of the circuit becomes minimum. So you can write here at resonance, impedance of circuit is minimum, and current in the circuit, peak current in the circuit is given by V naught by Z, and this V naught, what is Z? Z in the series LCR circuit having the condition of resonance R. So V naught by R. So current in the circuit, LCR circuit at resonance will be V naught divided by R. This is the minimum current. Okay, this is the minimum current. And so here what happens? This circuit becomes a purely resistive circuit. This circuit becomes a purely resistive circuit. So the equation of the current can be written as I is equal to I naught sine omega t, and equation of voltage also becomes V is equal to V naught sine omega t. Why? Because this circuit becomes resistive circuit, and in resistive circuit current and voltage are in same phase. So now I can write the equation of the voltage V is equal to V naught sine omega t. V is equal to V naught sine omega t, and 10, what is the value of the 10 phi? Now you will not know the 10 phi if you do not know the phasor diagram. Again I have to tell you. From this diagram, from this diagram, uh, if suppose your XL is greater than XC, then you can modify this diagram. This becomes like this: XL minus XC, and if this become XL minus XC, and this is R, and resultant of this will be Z, and this will be phi. Phi is the phase difference. Now if you will calculate the 10 phi, so you will get XL minus XC divided by R, and I have told you in the last class how to get this phi. Okay, we will complete this triangle, and this XL minus XC will be the perpendicular of the triangle, and R is the base of the triangle. So again and again I will not tell. So this is 10 phi. Now at resonance, what happens? XL becomes equal to XC, so this will become 0 by R. So 10 phi becomes 0. So your 10 phi becomes 0. So your phase difference phi becomes 0. Your phi becomes 0. So 10 phi becomes 0. So you can say your phi becomes 0. What is phi? Phi is the phase difference. Phase difference between current and the voltage. Between current and voltage. So first write this, then I will discuss later. Okay. Nida, if you don't know how to draw the phasor diagram, what is Excel, what is XC, all these concepts, if you are not getting, then you can go to the previous lecture or recorded lecture, okay, of mine. Because if I will explain those things right now, then it will take one more lecture. So it is better to complete it. Fawaz, Hamza, complete it.
Yes, sir.
Hamza, complete it. Okay, I think he has completed. I think this is almost completed. We have completed, I think, 90% of this chapter. So there is one more topic after the resonance transformer, and after that, this will be finished. Okay. So write down first. So I think in half an hour in the next class, I will finish this chapter.
Okay, sir.
Mm. So this chapter will be finished in the next lecture, maybe in first half hour. There is only one topic left, that is transformer. So that I will discuss in the next class. But please, chapter is completing on and we are moving forward in the forward direction. But don't forget to revise the previous things. Okay. Otherwise, there will be no use if you are moving in a forward direction and you are forgetting uh, what you have done earlier. Okay. Hamza, take the screenshot. Fawaz, completed. Okay. Fawaz, you can write in chat box only a small d. Okay, it will save your time.
Okay, okay.
Hmm. Okay, now write down this and Hamza, take the screenshot, and then we will discuss the resonant frequency. Resonant frequency. Done. Nida and Hamza, completed. Hamza, what about you? Hamza, are you getting my voice? Hamza, please check the screenshot, okay? Okay, so we will discuss what is resonance frequency, resonant frequency. Resonant frequency. So resonant frequency means uh, a frequency at which the inductive reactance of the inductor and the capacitive reactance of the capacitor becomes equal, means XL becomes equal to XC. And what is the XL? XL is given by omega L and XC is given by 1 by omega L. So you can write this as omega square is equal to 1 by, this is omega C. XC is equal to 1 by omega C. So this will become omega square is equal to LC. So from here you will get omega as 1 by under root LC. And this is your resonant angular frequency. So I will represent it with omega naught or f naught, omega naught or f naught. So this will be your, suppose this is your omega naught and this is also your omega naught. So this is your omega naught, this is your omega naught. Okay, now we know that there is a relation between the omega naught is given as 2 pi into f naught. So from here we can calculate the f naught, that is omega naught divided by 2 pi. What is omega naught? 1 upon root LC. So it will become 1 by 2 pi under root of LC. So resonant frequency is given by 1 upon 2 pi under root of LC. And this frequency is angular frequency. This is the only frequency. This is number of revolution in 1 second frequency. Okay, so okay, we will discuss what will be the average power, at resonance. Okay, average power at resonance. So for resonance, average power can be written as like this. Average, not for resonance, average power is given by Vrms Irms cos phi, Vrms Irms cos phi. I have just told you. And what is phi at resonance? 0. Just told you. So when you will put cos phi here, this will become Vrms. This is I RMS cos 0, and cos 0 is equal to 1. So average power is equal to Vrms Irms cos phi is 1. So this is your average power. This Vrms can be written as V naught by under root 2. This Irms can be written as V naught by root 2. So basically average power will be at resonance. This will be I naught. This will be I naught. Average power will be V naught I naught divided by 2. This will be your average power at resonance. And this power will be the maximum power. Okay. This power will be the maximum power because here the current is the maximum. Here the current is the this I naught is equal to I max, because at resonance, okay, I have to tell you, otherwise I naught in the LCR circuit, series LCR circuit is given by V naught by Z, V naught by Z na. So at resonance what happens, Z becomes minimum, Z becomes minimum, so current at resonance will become maximum. Okay, so this I naught will become maximum current. So you can write the average power as V naught and I naught max divided by 2, divided by 2. And you know that I naught is equal to V naught by Z, and what is Z at resonance? R. So instead of this I naught max, you can write V naught by R. Okay, so average power will become, this is V naught, and this is, in terms of this I naught max, you will put this V naught divided by R. So V naught divided by R, and this is divided by 2. So average power will become V naught squared by 2R. You can write this in terms of the current also. This will become I naught max square into R divided by 2. So this will be your average power. Write down. Hamza, are you there? Hello, Hamza. You can write in the chat box if your if your microphone is not working. Fawaz and Nida, write down. Nida, are you writing with me or just you are taking the screenshots? Okay, no problem. Write down this. Done. Okay. Fawaz completed. Hamza.
Sir, 1 minute.
Okay, no problem. This chapter is easy as compared to the other chapters like electromagnetic induction, like moving charges and magnetism, like electrostatic. This is very easy chapter when you will try to understand properly. So in the next class, I think we can finish this chapter in half of the lecture.
Done, sir.
Done. Okay. Hamza, hello. Done, Fawaz and Nida, both of you completed. Okay. So if you have completed, then in the next class, uh, okay, very good. In the next class, Nida, for you, I am saying because you were absent. So you should go through the video lectures or you can take help from some book if you want, whatever you want. But I want that at least you should know how to draw the phasor diagram. What is the root mean square value of the current? What is the average value? Okay. What are the phasor diagrams? Okay. So, okay. If you have completed all of you, then we will meet in the next class.
Sir,
Yeah.
sir, in the last, it is two, right? The
Hmm?
P
Yeah.
average.
This is two. This is
Okay.
two. This is also two.
Nice. Okay, thank you.